Hello everyone, and thank you for being here. My name is Bhusala Praveen, and I'm currently pursuing my internship at Emertxe Information Technologies Private Limited. During this internship, I had the opportunity to work on a simulation project that focuses on the internal working and control mechanism of a washing machine. The title of my project is Microcontroller Based Washing Machine Simulation using Picsimlab. Through this project, I was able to implement and simulate a fully functional washing machine using a microcontroller and software simulation tools, gaining hands-on experience in embedded systems design and development. This project was designed with the primary intention of simulating the core functionality of a washing machine in a safe virtual environment using Picsimlab. The simulation models how an actual washing machine operates, including a program selection, water level configuration, start and stop functions, wash, rinse, and spin cycles, safety features, and user feedback. The core objectives of this project included gaining an in-depth understanding of how various washing machine components and washing cycles function, implementing control system logic and software to manage real-time processes inside the machine, gaining practical embedded systems development experience using microcontrollers, particularly the PIC16F877A, learning how to simulate embedded systems effectively to minimize hardware dependency. This project provides valuable insights not only into the hardware and software interactions, but also into designing smart appliances using embedded technology. To bring this simulation to life, I used a specific set of hardware and software tools. At the heart of the system is the PIC16F877A microcontroller, a powerful and widely used 8-bit controller suitable for embedded applications. For the development environment, I used MPLAB XIDE, which allowed me to write and debug embedded C code efficiently. The actual simulation of the washing machine was carried out in Picsimlab, a virtual hardware simulation tool that models the behavior of microcontroller projects without the need for physical components. In addition, I used PicGenius, which is a virtual development board, a 16 into 4 LCD display to show real-time status of the machine functions. The entire software was written in the C programming language, giving me direct control over the microcontroller's registers and functionalities. The key advantage of this tech stack is that it simulates real-world embedded applications without requiring expensive physical hardware. This diagram gives us a high-level representation of the entire washing machine system. On the input side, we have various push buttons switches labeled as SW1 and SW6, which refers to switch 1 and switch 6. Each switch has a unique role, such as powering the washing machine, selecting programs, adjusting water levels, and monitoring door status. These inputs are processed by the PIC16F877A microcontroller, which is programmed to interpret user commands and operate the system accordingly. The outputs include the CLCD display that provides feedback and information to the user and the buzzer for safety alerts. Each section of the washing process, like washing, rinsing, and spinning, is treated as a separate state within the system and managed accordingly through a state machine architecture. This modular structure makes the system easy to understand, simulate, and expand. Next, coming to the functional requirements, we have several requirements that a washing machine needs to fulfill and a user looks to when he uses a washing machine. Let's take a closer look at the specific functional requirements and how they were implemented. The first and foremost requirement is power on screen, and the simulation begins with the power on screen. Here the system waits for the user to press switch 5 to initiate the washing machine. Upon pressing the button, the microcontroller initializes all system parameters and displays the message powering on washing machine on the CLCD display screen. This process mimics how a real washing machine boots up when we press the power button. And next we have the requirement 2, which is washing machine program selection. Once powered on, the user is presented with 12 different washing programs to choose. Uh, they are daily, heavy, delicates, whites, stain wash, eco cottons, woolens, bed sheets, rinse plus dry, dry only, wash only, and aqua store. which fulfills various needs of the user while washing the clothes. And then navigation is handled using switch 4, SW4. A short press moves the selection cursor down, while a long press confirms the selected program. Once the desired program is selected, the system moves on to the water level selection screen. And in the water level selection state, uh, we have several water level options, which are auto, which automatically detects based on the load, and low, medium, high, and max, which have to be selected manually. In this stage, the user is prompted to choose the desired water level. Options include auto, low, medium, high, and max. Auto mode detects the water level automatically based on load, while the other options allow for manual control. Again, navigation and selection are done using switch 4. Once confirmed, the system proceeds to the start screen. And in the requirements of start screen, uh, we have the screen displays the selected program and estimated watch time. The user can press switch 5 to start the operation, or switch 6 to stop and return to the program selection menu. Starting the operation initializes all required parameters and transitions the system into active monitoring mode. And then the system responses will be like display selected program and estimated time, initialize washing machine cycle parameters, transition to function screen, begin real-time operation monitoring. And then we get on to our fifth requirement, which is function screen. During operations, the washing machine goes through three phases: wash, rinse, and spin. Each phase is displayed in real time on the CLCD along with the countdown timer. For safety, switch 1 is used to simulate the door status. If the door opens mid-cycle, then the system activates the buzzer and displays a warning message, halting operations until the door is closed again. This feature mimics the door lock mechanism seen in real machines. And then we have system safety and door status, as we discussed earlier. If we press switch 1, the door will be opened, and when we release the switch, the door will be closed again automatically. And the safety action works as buzzer activates when the door opens during operation, and it will be closed again. When it will be closed again, the buzzer will be turned off automatically. And then we come to our sixth requirement, which is completion status. When the wash cycle is completed and the timer reaches 0, the washing machine automatically stops all functions. Then we have the completion logic and post completion actions. The completion logic will the completion logics are all washing functions completed, timer reaches 0, system ready for next cycle, and user notification displayed. And then post completion actions stop all motor operations, display completion message, wait for user acknowledgement, ready for new washing cycle. All these all these actions will be performed once the process that is once the wash cycle is completed. Then we have our development process and implementation. The development of this project was executed in a systematic manner that mirrored real-world software engineering practices. First, I conducted a requirement analysis to understand how a typical washing machine works and which functions are most essential. Then I moved on to the system design phase, where I planned the architecture and control flow using the state machine model. Next came to the code development, where I wrote modular embedded C code for the PIC16F877J microcontroller. After coding, I used Picsimlab to test and simulate every functionality from power on to program completion. I also implemented safety checks, memory optimizations, and timing mechanisms to manage each wash phase precisely. By using state machines, I was able to easily transition between different screens and modes based on user input, ensuring that the system was reliable and responsive. Now, let us look at this project demonstration and understand how the project actually works and how the inputs are being passed to the washing machine. At first, I'll be explaining the project in this PowerPoint presentation. Then we'll move on to the Picsimlab and I'll also show you how the simulation actually works. Coming to the PowerPoint, during this demonstration phase, I showcased the complete operational cycle. The flow began with the power on process, followed by a program and water cycle selection. Once the user started the cycle, the washing machine progressed through the wash, rinse, and spin states while actively monitoring the door status and user commands. I intentionally opened the simulated door during operation to demonstrate the buzzer and alert system, proving that safety checks are enforced effectively. The timer also worked correctly, and upon completion, the display indicated readiness for a new cycle. This demonstrated that the machine could handle a full workflow autonomously and safely. We are now in the Picsimlab interface, and I have already set up all the necessary things that will be required for the project, and I want to guide through the process I have went through in order to set up this. First, we have to select the bird, which is uh, pick genius, and then after selecting the bird we have to select the microcontroller. For this project we have been using pick 16 f8 6 f8 77a, and you can also see the microcontroller name here. Then after selecting this both, we have to load the project hex file into the Picsimlab, and I named the project file as washing machine xproduction.hex, which is a hex file. And after loading this, the interface will be like here. And then we have to set up our clock speed in megahertz and also select the LCD screen. For this, I have been using 16 into 4 screen LCD screen from the very beginning. And after loading all these settings, we can see the LCD screen here, which is 16 into 4. Uh, and it is uh, denoting like press key 5 to power on the washing machine. In order to select that key, here we have 6 keys we used in this project. They are RB0, RB1 and up to RB5, which can be assumed as switch 1, switch 2, switch 3 and up to switch 6, which is RB5. RB0 main function is to handle the operations of the washing machine door, and we haven't used RB1 and RB2 in this project. Then we used RB3 and RB4 for multiple purposes in this project. And then we have RB5, which is switch 6. And now uh, I want to demonstrate you how this project works. In order to start the project, we have to select the key 5, which is switch 5. And after clicking on that, the screen will be loaded and shows as powering on the screen washing machine. And after once the screen is loaded, will be directed to the program screen. There are a total of four screens in this project. They are program screen, water level screen, start stop screen and the function screen. This is the program screen in which we have to select the mode of the uh, washing. In order to switch between the modes, we have to click on the RB3, which is switch 4. By clicking on this RB3, the modes will be changed. There are a total of 12 modes in this program section, which we discussed earlier in the PPT. Now I want to select a delegate program which has the less time in these all options. Okay. Here we have dedicates as the third option. After navigating to the option, we have to long press the switch 4 in order to continue to the next screen, which is water level screen. Okay, after waiting for a certain period, the water level screen will be opened. Here we have a total of 5 options. In this, they are auto, low, medium, and high. and max. The navigation between these modes is also same as earlier. We have to press switch 4, then it will be changed between modes. Here you can see 5 modes. Auto is automatic mode, which selects the water level based on the load that we put into the washing machine. And then we have low, medium, high, and then maximum, which will be filling the washing machine up to the top. And for now, I want to select low mode for demonstration purpose. After navigating to the low, we have to uh, click and hold the switch 4 up to the next screen will be navigated. I'm re-navigating to the low mode. Okay, after selecting this, we have to click and hold up the switch 4. After that, we'll be navigated to the start stop screen. Here we have two options, start and stop. Stopping the process, we can press switch 6, then it will be redirecting us to the program selection page screen. And then we have start, which we have to press switch 5, then it will the process will be begin to wash and rinse the clothes. In order to stop, we have to press switch 6. So as soon as I click on switch 6, then it will be redirected to the program screen. And I'm again redirecting to the start stop screen. Now we have to press switch 5 in order to start the process. As soon as I click the switch, uh, a prompt screen will be appeared for 2 seconds, indicating the amount of time that will be taking in order to wash the clothes. Now, after clicking that, uh, the timer will be start and the fans will be uh, rotated. And here we have uh, a function that will be uh, sounding buzzer when the doors will be opened or closed. We have the switch 1. If we press the switch, the doors will be opened and buzzer will be sounded. As you can see, I turned on the buzzer, and whenever I press open the doors in between, it will be sounding the buzzer. And also, if we press switch 6, it will pause the process for some time until we press the start button again. Now I'm pressing start. Then the process will be resumed. After the completion of time, as you already saw that there are three modes: wash, rinse, and spin. And after the completion of the process, the, the buzzer will be sounded for 3 to 4 seconds, and then it will be redirected to the program page. And I forgot to mention one more option, which is reset. If you press this button, then it will be redirected to the uh, first screen, which will be indicating press switch 5 in order to power on the machine. And that's all about the project demonstration. As I reach the end of this presentation, I would like to take a few moments to reflect on the broader significance of this project and what I have personally gained from it. Working on the simulation of a microcontroller based washing machine has been far more than just a technical exercise. It has been a journey into the real world application of embedded systems and how they power the smart appliances we interact with every day. Throughout the course of this internship project, I was able to move beyond theoretical concepts and actually apply embedded programming, hardware simulation, and system design in a structured and meaningful way. One of the most important takeaways for me was the value of modular thinking and structured coding practices, especially when working with state machines and time sensitive operations. Learning how to manage different functionalities such as inputs, safety protocols, timing mechanisms, and display outputs gave me an appreciation for the complexity behind even seemingly simple home appliances. I also gained practical skills in debugging, simulating hardware behavior, and optimizing system performance within the constraints of a microcontroller. These are the skills that I believe will serve as a strong foundation for more advanced projects in embedded systems, IoT, and real time automation. Overall, this project not only deepened my technical capabilities but also sharpened my problem solving mindset and helped me understand the importance of user experience and system reliability in embedded product design. Before I formally conclude, I would like to express my heartfelt gratitude to everyone who played a part in making the project a success. First and foremost, I want to thank the entire team of Emertxe Information Technologies Private Limited for providing me with this valuable opportunity. The, the structured internship framework, the technical mentorship, and the collaborative learning environment were instrumental in guiding me through the entire process, from understanding core concepts to actually building a fully functioning simulation. I would especially like to thank my mentors and instructors for their continuous support, timely feedback, and encouragement throughout the duration of the project. Their insights not only helped me troubleshoot and improve my code, but also deepened my understanding of embedded systems as a whole. To my peers and fellow interns, thank you for your collaboration, idea sharing, and team spirit, which made the learning experience even more enriching and enjoyable. And finally, I want to thank all of you, our audience, for taking the time today to listen, learn, and engage with my work. I truly hope that this presentation has given you a meaningful look into the inner workings of embedded system design and how simulation tools can be effectively used to model and build real world applications. Okay, I'm thanking everyone who came across all this PowerPoint presentation, and I hope you understood my project well, and thank you again for being here.